So we're going to talk about how we can use PMM to troubleshoot some of the problematic MySQL queries that you might find in your environment. This talk is dovetailing on what you've already heard from Peter earlier, where we talked about observability in MySQL 8. And then it also includes some components of what Mr. Benschoof was just speaking of around schema design and how you can optimize your queries through different techniques. I'm going to mention some of those, but I'll be focused more on how we use tools to actually get at which queries do we want to spend our time on first. So I'll just talk quickly about who I am. I'll go through a couple different methods that are popular in the industry right now. And then at the end, depending on how much time we have, I'll try to get through a demo. So for those of you who've been seeing some of these Percona talks for a while, I've been around for about 8 years with Percona. I started as a MySQL consultant. I'm back on the MySQL team now, and I had a sprint there, maybe about 2 or 3 years, where I was a product manager for PMM, which was really a great opportunity because it let me focus on the database technology that I'm comfortable with and enjoy working with it as MySQL, and then refine it by visualizing and putting metrics around it or measuring metrics using PMM. So I'm using both of those today. I love to run, I love to swim, and I'm a dad. Not necessarily in that order. I like being a dad first among all those three. And I've been working on some really cool projects lately, not directly related to the topic today, but I've been working with our PXC operator for Kubernetes and also had a very long engagement around Proxy SQL. I can't say it enough. Both of these are the bee's knees kinds of products that'll help you in your environment if you're looking for high availability and redundancy. So at some later time, I'll be having some specific talks on where those technologies fit in at Percona. But for today, we're going to focus on problematic queries and query performance. Okay, so what I focus on with problematic queries, I'm looking at ones that consume resources. And those resources are constrained by whatever provider you're using, whether it's on-premise or whether it's a cloud platform or whether it's a containerized service like Kubernetes or OpenShift or any other of the mixes in between. You only have a finite amount of disk throughput, disk space, CPU, RAM, and memory. Oh, sorry, RAM and memory are the same. And so there is a finite limit. So we need to account for all of these different criteria. And at some point, you're not going to be able to buy any larger of an instance. You're not going to be able to get additional capacity for IOPS for your disk. So what we always want to do is keep ourselves vigilant on which queries are consuming those resources the most. And I break this down into 2 types of queries. The first, I think, is the more common one that we think of. MySQL has a phrase called slow queries, which goes to the slow query log. By default, you're setting at some relatively high threshold with it. What a slow query is anything that exceeds the threshold. And a threshold, you might say, well, queries longer than 5 seconds are a problem in my environment. Of course they are. That might be something where your page is loading for your shopping cart, what have you. And a 5-second delay can lead to abandonment of your cart and therefore less revenue for your organization. So slow queries are queries that run one at a time and are just very long to execute. But the other one that consumes resources but doesn't always show up when we're using our slow log in the default configuration are queries that run relatively quickly, each of them, maybe 10 milliseconds, 100 milliseconds, which by itself is great. But when this query might run 1,000 or 10,000 times a second, that's a significant amount of work that your MySQL server has to account for. And so we need to treat those as actual activity generating and resource consuming queries, but we've got different approaches for what we do about them. So I don't want to tread too much on what Mr. Benschoof was talking of, but what can you do about query performance here? Well, the first one gets into rewriting the query. You're often loath to do this because you might be bound to a certain format of your query, be it based on some framework. It's a hibernate query and you have no opportunity to change the syntax of it. But if you are able to rewrite it, some things you can do are to do less joins between tables, or you can use things like index hints. Okay, the point being is you want to access less data and therefore consume less resources. But option A isn't very common in the world of more and more frameworks. You don't have access to edit raw queries anymore. Okay, so what do you do about it otherwise? We want to modify the schema. You likely will want to add additional indexes. And this is relevant to the type of query that runs, 3 seconds, 5 seconds. If you add an index, therefore you can drill down more quickly to the data that your query is seeking, and therefore you can return the results set quicker to your app. That usually means adding new indexes that weren't there before, or you can remove old ones because every additional index can add some penalty to the optimizer that has to seek and determine if it's an appropriate index to use or not. So you might find yourself in both worlds where you're going to add or remove old indexes. And then thirdly, another method that's common around query performance is to work with caching. And caching applies to that type of query that runs relatively quickly, the 100 milliseconds, but thousands of times a second. You can't do anything about making the query itself run faster necessarily, but what you can do is offload that query activity from the server. And it used to be that you'd use the MySQL Query Cache. That's been deprecated and removed in MySQL 8. There's no more future of the MySQL Query Cache. But I wanted to mention it because that's usually the first thing that people are thinking of. If you use other technologies, you can use Proxy SQL, has its own query cache. But you can also use other technologies outside of MySQL. Maybe you have your app fronted with Memcache or Redis. The point being is that you might want to cache these queries before they get to the database, and therefore take that load off of MySQL. Okay, so enough about the background on what it is we're looking for. What we can look at now is how do we actually drill down and find some of these bad queries. And I'm going to speak about the RED method, acronyms, we all love them, which is inspired by the USE method, yet another acronym from Brandon Gregg. And then we're going to look at how PMM Query Analytics actually uses the concepts out of the RED method, and we can drill down and find specific queries that are the offending ones that we might want to tune. Okay, so a quick background. The USE method is based on Brandon Gregg, who's done a lot of infrastructure related work. He's been at Netflix for quite some time, and he's been quite published around his activity on profiling of infrastructure. Okay, USE, the acronym, stands for utilization, saturation, and errors. We are generally measuring infrastructure. How many of my VMs are utilized right now? How much of my CPU is being accomplished? How deep is the queue of work, which is relevant to saturation? And finally, errors. How many errors are ongoing in my environment? I'm not so concerned using the USE method into what is an individual server's performance, but I do care about my MySQL replication cluster. What is the health of the primary and the 4 read replicas? What is the count of errors across that whole cluster? That's where USE is really helpful, okay? But what it's not so great at, there are other characteristics that affect the performance of your database server. One of those is I/O errors, whether that's through the network interface or more likely to the disk. So the USE method doesn't necessarily filter up to us when we're stalling on disk, for example. We get into that when we use the RED method. The RED method is from another gentleman who's been in the metric space for quite some time. His name is Tom Wilkie, and he was working at Weave Networks, which is working around Prometheus and other time series databases. And RED stands for rate, errors, and duration. So the rate is very similar to the error count. We're talking about the number of requests that were served, and in our method, we're going to be talking about the number of queries per second. We've got errors. Again, it's the same sort of ratio over time or rate over time of the error failures. And then finally, the duration, the latency. How long are these queries taking to execute? So slightly different than the USE method, okay? And this is all based on another topic that Tom pulled this from called the 4 golden signals, which is related to latency, traffic, errors, and saturation. So kind of a hybrid of the USE method. So let's get into what RED actually means. Well, thanks to Peter, who spoke first today, he actually developed a dashboard called the RED method for MySQL Queries. When you download this presentation, you'll be able to click through that link and you'll get to grafana.com/dashboards, which if you already got PMM running, PMM version 2, it uses ClickHouse as a background database. And you can pull down this dashboard, import it, and a couple clicks later, you'll have it working for your environment. So it's really easy for you to get up to speed if you've already got PMM deployed for following through this topic and along with the demo that I'll do at the end. You'll be able to implement the RED dashboard and also the query analytics. And what are we going to look at? We're going to look at 4 main components of the RED method dashboard. We're going to talk about the query rate, total errors, query latency, and then a bonus one. It's not really part of RED, but I think it's immensely powerful of what we can get when we inspect our query data using PMM, okay? And before I get too far, I just want to add, how did we get all of this data? The data we're collecting in my environment is coming from the MySQL slow log, but you can also use performance schema. PMM server and with PMM2 client, they will automatically source these locations and start pushing query data up to PMM server for you and storing them in a database called ClickHouse. There's extra detail there that you don't need to be aware of necessarily for you to use these dashboards, but when you're going through the import, you'll see, you know, what is my ClickHouse data source and what is my Prometheus data source. You'll click some radio buttons and things will just work. So don't be surprised when you see ClickHouse there. The point is I want to be able to show this rows examined per query because it's immensely powerful to talk about how our indexing strategy works. But let's come back to query rate. Query rate is something that we talk about. You can get it out of regular PMM or many other tools. What are the queries per second that are running within my environment? And what this dashboard gives us are two different ways to look at that. We're always measuring the number of queries over the time interval we're looking at to get the queries per second. So in our case, the dashboard will show us what the overall throughput for our entire cluster. And in my case, I've got a 4-node cluster. I've got a primary called Percona Database, and then I've got 3 other workers 1, 2, and 3. So we can see down here at the bottom that they're actually individually noted as to what their query performance is per seconds, and then what the total is. Nothing rocket science yet, but the red dashboard covers off the first R. Then we get the error rates. It breaks down the same way. What we're doing here is we're measuring the number of queries that had errors divided by the total number of queries. So we're in a relatively safe place for error rate. We're below 1% of total queries that were running during this observed period. And we also get a breakdown of the error rate per node. So we can then take not only what my overall health that I might give to an SRE engineer, or to somebody who may not know my app as well as a developer, but who's responsible for responding to alerts. They will look at the total error rate and determine if there's anything deeper worth investigating. In our dashboard, the next graph worth investigating is which server or which instance is having the most errors. It happens to be right below it. So it's very easy using the red dashboard to be able to navigate to which server's throwing the most problems. And then finally, the most significant one I think that most users will care about, that matters probably the most applications other than availability, is what's the latency on queries. And what I love about this is it actually gives us the average in the P99, the 99th percentile. So what that's saying is that of all the queries, P99 is defined as all the queries that are running in my environment, what are the ones that are running at the 99th percentile, meaning which queries are the outliers? What are my slowest performing queries? Not the worst one, which would be the 100% percentile, but very, very close to the edge. And that's useful for us because the average can smooth out any significant spikes, as illustrated by this graph. On average, our max only hit 34 milliseconds. Really not that bad. But we know at some point in the past around 640 that there was a spike up to about 800 milliseconds. So that's the only way that we can see this if we use the P99 latency. Okay, so that's great. Now I know I have a spike. If I was an SRE, I might want to log in and dig into what happened around 640. I can then jump down immediately to my screen below and see which of my workers probably contributed the most to this spike. And again, the top graph is an aggregate, so that's why the numbers aren't exactly smoothed out to, we're not seeing a average query latency per node that's spiking to 800. But we do see worker 2 had the most significant spike. So the premise being is through this red dashboard, again, we can see that query latency deviated. We don't know why, we don't know which queries yet, but we do know that we have a reason to investigate. This is a classic case, I would suggest, that you might want to alert on, and then have somebody dig in to look at those specific instance and then drill deeper to see which query or queries contributed to the stall. Okay, this one I just want to mention because it's not really part of red, but it is fantastically important and useful. When you're developing, this is back to Mr. Benshoof's talk a little bit, when you're developing your index strategy, your goal is to get down to, if you're going to use an index, that your ratio of rows looked up by index versus rows sent to the client is 1-to-1. So I want to have my indexes be as selective as possible. So a ratio of 1-to-1 is the goal, and that would look like on this graph a flat down at the bottom. What we're actually seeing in my scenario right now is that there's 2 different workloads it seems to be here. Percona Database is a bit higher, and it's floating around 2,000 rows returned out of the index, or sorry, being sent back to the client. So what that says to me in general is that the indexes are not as selective on Percona Database as they might be for the other 3 worker nodes. That's not necessarily an actionable in the heat of the moment, I've got a problem, but this is more that I would take back in my tech debt sprints, or I might take back to my developers over the water cooler and say, guys, what is interesting about this particular server? Why is the number of rows returned higher than in the other servers? It is a data point for you to compare and observe the differences between workloads and between instances. Fantastically important. Okay, so now what do we do about this? Well, when you're using, excuse me, PMM, you have built into it two components. One is known as our metrics platform, which is built using Grafana, which gives you great graphs on the behavior of your operating system, how much RAM is being used, your MySQL instance, what is the value of threads running, and plotting these over time. Fantastic views, but I'm not going to get into that here. Part 2 of PMM that I will focus on is called Query Analytics. And again, that has the queries being collected from each of your database servers, being pushed up to PMM server, and then we do some queries against that data to then render these visualizations. So we talked earlier in the red method, we were looking at latency. We wanted to find out which queries are taking the most amount of time. Well, what you can do in PMM is I'll get into the demo and show you how to actually do this, but you can set your fields to anything you want. One of those will be query time. And we can get then what's called a sparkline view, which is underneath the query time, which shows you how those values are changing. So this, I think, is an hour-long capture. At the start of it, query number 3 wasn't running at all, but halfway through it started to come up. We can see as the peaks and troughs move from left to right. We also get it sorted based on the queries that took the most amount of time. So this is based on averages here. So we have one query that on average is about 120 milliseconds, and the next slowest set of queries is row 2 there at 26 milliseconds. So if I was working, if this is my production environment, I might want to come back to my development team, determine the app and the logic that led to this select count from SB test 1, and say, what can we do about this? Well, all I know it's slow right now. I haven't done any other investigation into other characteristics about this query, but we know it's slow. So put that one in our back pocket. Another way to look at it is what's the load on the system? And this gets into the, I forget which letter now, the R from the rate. We can tell which queries are causing the most amount of activity on MySQL. Not necessarily the slowest, but the ones that are consuming load, okay? And you just leave that by what we call our load header, and that is actually the default view when you load PMM Query Analytics in your environment. And just to be clear, I'm using PMM Server 2.9. So in 2.9, we released a full revamp of the UI for Query Analytics. So if what you're looking at in your environment looks a little bit different, it's time to upgrade, get 2.9 deployed, and you'll really benefit from it. It's a lot faster, it's a lot cleaner. They fixed a lot of bugs. But anyway, around load, this is the number of average active sessions that are running. How busy is this query in terms of activity on my server? Okay, now we are also concerned about our other significant resource, which is usually one of the main bottlenecks in MySQL activity performance is the disk. Now you can buy different qualities of disk. If it's an on-premise, you're usually stuck with whatever purchasing decision you made, and you might be in that technology for several years. If you're in a cloud, then you have the opportunity maybe to move between different types of storage more easily, okay? But the premise being, generally MySQL wants faster and lower latency. I'm sorry, higher capacity and lower latency. And what that means is, if you're going from spinning platters, which have a maximum rotational speed, to something like SSD, that means the latency for you to get an operation done will be quicker. And the other characteristic to look at is how many input-output operations can you conclude in a given second to a spinning platter versus an SSD. And generally the bandwidth capability is higher in an SSD. I'm sure you guys have heard this plenty of times. There is difference in the quality of disk. MySQL benefits from having the highest quality that you can put under it. Because the premise being is that every type of read and write potentially can be fetched from disk if it's not already in the buffer. So the faster the disks are, the faster the query performance will be. Well, how do you evaluate that? If you're using Percona Server, we have what's known as the extended slow log format. And what I do is I set the slow log value to be 0. I just want to call all queries slow. It kind of muddles the definition of slow, but that's what we have. I want all my queries going into PMM Server. So that's the first goal. Second goal, when you use the extended format, you get deeper information, richer information about what InnoDB is doing within the specific query itself. So in this case, I want to evaluate how long has InnoDB had to wait for reads from disk. And by sorting by this, I can then start to see if I have to go back to my app team and investigate this deeper, I can show them which queries are reading the most amount of activity from disk and therefore being delayed the most. I can get the number of reads that are occurring from another field called IO read ops. Okay, so a combination of read ops and read wait hint to you where disk has become a problem and which queries are impacted the most by your selection of whether it's disk technology, or maybe you need to buy more IOPS from your provider, etc. You've got a number of different options to move forward from. But first, these screens will educate you on which which queries or which areas to look at first. In this case, we're talking about the IO. Okay, what else can you get out of it when you're using PMM? I've highlighted just a few of the high ones, but if you have a query that is running on Percona server with the extended slow log format, you'll get n number of different columns. Sometimes it's more and sometimes it's less. Updates have different fields that show versus selects. Okay, but the point being is that the richness of the extended log format also enables you to do sorts based on that in PMM query analytics. So it's, in my opinion, if you're running Percona server, you should have the extended log format enabled and be using the slow log. A caveat, you don't get this richness of data on Percona server for MySQL if you're using performance schema as this query source. Okay, so it has to be the slow log. But this is what you get: beautiful graphs, spark lines, and different values per type of metric that you get out of the slow log. Okay, and what else do you get right before I go to the demo? You get some schema information that is relatively trivial to mention, but it saves you a lot of time. The more enterprise customers I've started to work with, the more I've discovered that even those database engineers and myself have two-factor and other ways of restricting my access to those database servers. So it gets to the point where it's not prohibitive, but it certainly costs me more time, and I don't really necessarily want to get a shell on a database server anymore because it just takes so much extra work. Well, one of those quick hits is that my PMM server in 2.9 will give you the create table, the show table status, and the show indexes. Okay, again, things you can collect, they're very generic, but having them all in one view is really, really enabling for you to quickly review what indexes are set up on the server. Do I have a primary key defined, and what is it? How many rows are in the table? If I add a couple columns together, the data length, index length, I can tell how much tables, the size of the tables are. So these are all really important pieces of information to have in front of you. Okay, let's get to the demo here. Okay, so we're within PMM Query Analytics, and I want to highlight a couple different data points here. This is the field in the section where you'll want to change. We're already on load. Let's set it to the InnoDB read ops. I've already got a time period selected, and I'm looking, I believe, at the same time period as I showed in the prior slides. So what we can get is a dynamic list of all of the queries, and there's 62 distinct queries in my environment that are running with my filters. Now, I've got a filter set just for the production workload. There's also some Postgres queries in here that I just wanted to filter out. That's why I selected an environment production that I enabled through some labels. So what do we get when we drill into this? Well, we already have the sorted order, which queries took did the highest volume of read operations from disk. I'm looking at a select because they're generally more expressive in terms of the fields that we get in the slow log. And I'll highlight here, let's get all my toolbars in order. We have the metric section right here, which again I showed, and we have some flyouts that help you describe what each of these different metric values are trying to explain to you. Okay, so what is the volume of data, the bytes sent back to all clients? A neat thing about these spark lines now is you can hover over them and get per minute interval values and what the rate is and what the time period is. On the far right side, we have this cool little widget that gives you the min, max, average, and 99th percentile for that specific metric series. So what it informs me about, in this particular case, rows examined. Let me choose another one that isn't in milliseconds. Okay, here we go. So lock time. So my minimum locking time is very, very low, but I do have a max up around 14 milliseconds. So a fairly widespread in terms of locks. But when I look at my 99th percentile and I'm still less than 1 millisecond, I'm probably inclined to discount that there was one erroneous max value and all the rest are relatively quickly performing in the sense that there's very little locking for this particular query. And we're getting towards the end of the talk. I do want to add, just based on something Mr. Benschoof mentioned towards the end when he was talking about the growth of your database, we do have a dashboard called MySQL Table Details within PMM, and that can give you both based on row count, your table sizes, the amount of space on disk it's taking, and then it can even plot your database size over time. Now, again, I have a synthetic workload here, but we can see it went from nothing, and very quickly, when I was running Sysbench to populate the tables, they very quickly filled up and we achieved a flat line. So with a graph like this, you can use that compared to the available disk space you have and make some projections as your data set is growing as to when you're forecasted to maybe run out of disk or when you need to make a critical call at 90%, when do we need to add more disk, add another VM or what have you to your environment. I'll leave off with saying that the dashboard link is available on grafana.com dashboards. If you search for the red method or just click the link that was in my slide deck, you'll have the ability to get the red method for MySQL queries alongside your environment of PMM. And this is what it'll look like when you get it deployed in your PMM server here. You've got the graphs that I highlighted around the query rate, errors, and latency. And then down at the bottom, we get into some interesting ones where I talked about the row-based efficiency and some other different ways of looking at load and writes versus reads within your cluster. So very informing for you as a database engineer to use both the red method and PMM query analytics to help you identify which queries are performing the slowest based on the red method.